Examine each of the following patterns or numbers and determine the pattern has a linear or quadratic relationship. If it has a linear relationship, what happens? The first difference is always the same. So do you see in part B the way the first difference is always the same? That'll make that linear. You cool with that? Now what about J? What you see here? 10, 20. Next one? 38. After that? What do you reckon that is?
36.
Oh, sorry, 28. Next one is 36. 28 and? Now that's the difference of the difference. What do we see here? 10, 8 and? Oh, sorry, the first one's 12, isn't it?
Yeah.
So 12, 20, 28 and 36. So the second difference is the same. Would you agree with that?
Yeah.
What does that make that one?
Alright.
Yeah. Are you happy enough you know how to do them all now? If the first difference is the same, it's linear. If the second difference is the same, it's quadratic. We all cool? Alright, let's keep going. Write an algebra expression to represent each of the following number patterns. Alright, no bother. Alright. So, what's the first gap? Here to here. 4 here to here. 12 here to here. 20 here to here. Anybody? 28. Yeah. Alright. Second difference. What? 8. Next one. 8. And next one after that? 8. Alright. I think we'll just use the TN expression if that's cool with you guys. So, does anyone remember how to do quadratic sequences? Alright, this is junior cert stuff. Tn equals an squared plus bn plus c. You cool with that? Okay. Where do you get the a value from? Half the second difference. So what's the a value? Okay, awesome. Now, next thing you're going to do after that is probably a simultaneous equation, okay? So, which one do you want to be T1? Suppose T1 is minus 1 and T2 is 3. Is that right with you guys? So, what do we replace all the n's with? No, with 1. And the answer is minus 1. You on board so far? And then what do we get then? 4, oh sorry. Actually, it's going to change these two around the same time. The answer is going to be b plus c equals what when we bring over the 4 over the other side? B plus c equals minus 5. Everybody cool with that? What do we do next? Use T2. And what happens when I use T2? What do we replace n with this time? 2. 4 times 2 squared plus b times 2 plus c. And what is T2? 3. And then we get 2b plus c. Now that's 16. Everybody cool with that? Bring it over here so it's minus 16. So okay. Do you see these two simultaneous equations? Okay. Oh, that's a terrible choice in colour. That one there and this one here. So here's what I'm thinking. We get the red equation and take it away. So what do we get then? Plus 5, yeah? And then b equals minus 8. And if b equals minus 8, what's c? C will be 3. Okay. What's the equation then? Huh? Yeah. 4 n squared minus 8n plus 3. Has anybody got a way to check that really quickly? Lazy man's way. Table function. What do you want me to put in? I have to use x, don't I? Creevy, will you check the answer in the back of the book for me while you're there? Just while you're waiting on me? Because I think I have to do a small adjustment at the end. I had to start at 1, don't I? Because T1 is the start for me, isn't it? And what answer should I expect? T1 is minus 1 T2, T3, 15. What's the answer back?
Just 2a.
Yeah.
4x squared minus
4x squared?
1 minus 1.
4x squared minus 4.
6 minus 1.
Really?
2a.
Yeah, 2a.
He's right.
Yeah? Alright, I'll have a look at that now. Would everybody be happy with me using y equals 4x squared minus 8x plus 3 there? If I was to use what I got. Now Queven says, the back of the book says what? What does it say?
4x squared minus
4x squared minus 4. Right, give me a second with that.
1. Minus 1.
Say 4x squared
Minus 1.
minus 1x.
Just 1.
Just minus 1. Right, I'm interested. Right, let's just have a look at this. 4x squared minus 1. Right, there is a chance they're starting off at x equals 0. And that would affect numbers. Right, let's find out. By that logic, if I put this equation that you just gave me into this calculator, now if I start at 1 and end at 5, we can see that I'm ending up with completely different numbers. Is that alright? However, if I start at 0 and end at 5, all of a sudden it matches up, doesn't it? Now there is a problem with these questions, and I think that's part of the reason why I didn't do it. I did nothing wrong, because it doesn't specify that you start off at x equals 0, does it? So, I think what happens here is, if you go back here, and I'll show you a different way of interpreting them. So, I think what they're claiming is this. I sort of started off the first one is x equals 1 for me, but the back of the book is reading it as x equals 0. So if that happens to you, it's best to do something like this. Ready for this? T0 doesn't really exist, does it? So T0 is x equals 0. T1 is x equals 1, and T2 would be x equals 2. Is that right with you guys? Now what happens if I do the Tn formula again? Like so. I'm just going to go through it again one more time. Okay? Except this time, what am I not going to do? I'm just going to ignore the minus 1's existence. It doesn't exist to me. Alright? And let's see if I get the same answer that Queven thought I should have got. Okay? So, what's T1 this time? What am I using for T1 this time? Huh? Exactly. So I'm actually going to get A. Sorry, we already know A is 4, don't we? We knew A is 4, didn't we? Because it's the second difference from earlier. So what's that going to be? It's going to be A plus B. It's going to be B plus C. And the minus 4 travels over the other side, and what happens? Minus 1. Keep that in mind. Now let's do T2. This time T2 is 15, isn't it? Because we're basically ignoring the first part, right? So what's T2 then? Anybody? 4 by 2 squared, yeah. Plus B by 2. Plus C. Plus 15. And then 2b plus c, that turns into be 16, is also minus 1. Everybody see my two equations? Okay. Now what happens this time? Anybody care to tell me? Top one by -1. 2b plus c equals -1. Do you remember doing these at junior cert? Something similar anyway. What do I get? Oh, it is, isn't it? Thank you. I get b equals 0. And if b equals 0, what's c equal to? And that creates the equation that Quivian's talking about. 4n squared minus 1, which is y equals 4x squared minus 1. Is that alright with you guys? Alright, here's the issue. I want you to do part B, except I want you to do one little trick for me. To get the answer in the back of the book, it's a poorly designed question because it doesn't specify where x starts from. Is that alright with you? To get the answer in the back of the book, what I'd recommend is this. Just ignore the 4 and just say that T1 is 3 and T2 is 0. And then do the same procedure I just did. Off you go. First thing you're going to need is the A value. So you need to get the second difference, okay? So it's going to be minus 3, minus 5, minus 7, minus 9, and minus 11. Did anybody get the second difference is minus 2? What's the A value going to be then? Half of minus 2, which is minus 1. You know straight away that this is going to be a minus n squared plus bn plus c. Okay? What we saying T1 and T2 are? Huh? Yeah, T1 is 3, T2 is 0. The book doesn't tell us that, we just know by looking at the back of the book how the answers should work, okay? Then replace all n's with 1s. Then we get b plus c equals 4. Okay. Next thing you're going to do is go for T2. T2 is going to be minus 2 squared plus b times 2 plus c. That equals 0. I'm about to get 2b plus c equals 4. Again. Okay. Then we're going to take the two of them away from each other. We're going to get 2b plus c equals 4 minus b minus c equals minus 4. I believe I'm about to get b equals 0 and c equals 4. Alright? And that means I'm going to get Tn equals minus n squared plus 0n plus 4. Is that the answer to the back of the book? Minus n squared plus, minus n squared plus 4, otherwise known as y equals minus x squared plus 4. Good. Alright, let's move on. So question 2 was actually decently difficult. Question 3 is easier. Okay. Now, this is the key piece of information that the other one was missing. Just the key piece of information question 2 was missing. What does it say up here? What's that say? It specifies you start at 0. Everybody see that? Okay. You could use linear sequences if you wanted, but there's no real point, and I'll explain why. So, see this here? Let's just call that y. Y equals ax plus b. I, for argument's sake, I'll take question 6, okay? That's x equals 0, that's x equals 1, that's x equals 2, that's x equals 3, and that's x equals 4. If it was to draw them as points, they'd look like this. 0 minus 1, 1 minus 0.8, and then what's it, 2 minus 0.6. Is that okay? Now here's what we're going to do. What's the y value of the first point? What's the x value of the first point? Huh? Therefore, what's the b value? Okay. Pick the next point. What's the so y is currently equal to ax minus 1. Right, what's the y value of the second point? What's the a value, what's the x value? Therefore, what must be the a value then when you move 1 over the other side? 0.8 minus 0.8 plus 1 is 0.2. Alright, what's the formula so? Y equals, anybody? Minus 1. Right, that'll work perfectly for x greater than or equal to 0. Is that alright with you guys? Alrighty. Alright, so everybody remember the answer to the question? Everybody remember question 3 a second ago? We're just going to use y equals ax plus b. Is that alright? What do I have to start off with this time though? 3, 4, 5 and 6. Is that okay? Now, what's the y value in the first one? Anybody? Yeah, 11 equals 3a plus b. And what about the next one, 13? 13 equals plus b. Happy enough with that? Do the top one, take away the bottom one. Let's go and take away the bottom one. And what's the answer for a then? A is equal to 2. And if a equals 2, what's the answer for b? Sorry, spoilers. 6 plus b, so b must be. Wait. And the answer will be 2x plus 5. Your homework tonight is on YouTube. It should take you 26 minutes. Actually, I'm adding in 5 as well. Is that okay? So what did I do? 1, 2, 3 and 4.